Hi everyone, today we are going to talk about our first conic section, parabolas. This is just a really quick overview of the different conic sections we're going to cover and why they call them conic sections. So if you have two inverted cones and you intersect either one or both of the cones with a plane going at different angles, you can create these four conic sections. So here you can see if you have a slanted plane like this, you're going to create a single parabola. If your plane is exactly parallel to the base of your cones, you'll create a circle. But as soon as that plane is no longer parallel, it's going to create a more oval shape, which is called an ellipse. And if you have a plane that is perpendicular to the base of your cones, it actually creates what's called a hyperbola, which is like two parabolas facing away from each other. All right, so we're going to focus today on just parabolas, and this is the formal definition of what a parabola is. So by definition, a parabola is a set of points, so that's the points on this blue line, that are all equidistant from two things, what's called the focus and what's called the directrix. So if I take any point on my parabola and I measure this distance and this distance, it will always be congruent. So this is the formal definition. And notice that we do have two other characteristics that we're going to be working with, the focus and this directrix. So let's talk about the standard form for parabolas. There's two types of parabolas, vertical, which would go up or down, and horizontal, which would go right or left. So these are the standard forms that we're going to use this year. I did want to put in this vertex form because this is what was introduced to you in your Algebra 2 class. It looks slightly different, but it's really just the same formula rewritten. So imagine you take this constant and subtract it to the other side. That would give you this y minus k. And then imagine you multiply both sides by 4p, and that's what brings the 4p to the other side. Now, these are the two forms that I would like you to use for this class. Now, looking at these, there's three things that you'll notice. We have h and k, which of course are the vertex, but now we have this new p-value. So this p-value is going to help us find the coordinate for the focus and the equation for the directrix. And so if we think back to that last slide, the distance from the vertex to the focus and the vertex to the directrix is always going to be p. And of course, if our graph is negative, it's going to be facing down or to the left. So p is going to be something that we're definitely going to need to find in order for us to have a complete graph. All right, so first we're going to work on just making the equation. So it says find the standard form of the equation of a parabola with a vertex at the origin. Telling us that we're going to have h equal to 0 and k equal to 0, and a focus at 2, 0. So for these, I find them easiest just to kind of sketch out what they look like. So if I have a vertex right here, and my focus is here, I know that my graph is going to look something like this, which means it's going to be a horizontal equation. So we can find that standard form for that, and remember that's the y minus k squared equals 4p times x minus h. So we already know h and k, but we still need to find this p value. But if you remember, p is just the distance from your vertex to your focus. So we know that p equals 2, and we can just plug that in. So we have y minus 0 squared equals 4 times 2 times x minus 0. So we just have y squared equals 8x, and that's our equation. All right, go ahead and pause the video and give this one a try. Okay, so here once again, we know h and k are going to be 0. We know that p is 3/8 because that's the distance from your vertex to your focus. And so this is our equation. And if you kind of sketch out the information you're given, you'll see that it is an upward facing parabola, so a vertical parabola. So let's try another one together. This one is really the same idea, except the vertex is no longer at the origin. So let's give this one a try. I'm going to just sketch it out just so we can kind of visualize what type of parabola it is, which way it's opening. So I can see that we'll have a vertex at 2, 1 and a focus at 2, 4, which tells me that my graph is going to look something like this, which means it's a vertical parabola. So we have x minus h squared equals 4p times y minus k. And then looking at the information we're given, I can see that h is going to be 2, k is going to be 1, and I can see that this distance from our vertex to the focus is 3. So that's our p-value. And then from there, all you need to do is plug it into the formula. So we have x minus 2 squared equals 12 times y minus 1. And this is the equation in standard form. All right, go ahead and pause the video and give this one a try. Okay, so same idea. Sketch it out so you can see that this is actually a horizontal parabola. We can see that h is 2, k is negative 3, and our p-value is 2. Okay, so now we're going to do something a little different. Here we're going to start with our equation, and we're going to find the focus of this parabola. So when it's in this form, we know that there is a way to find the vertex, but for us to find the focus, we need to find that p-value. So we're going to need to rewrite this in that standard form. So the first thing I'm going to do is just multiply both sides by negative 2 just to clear my fractions. So we get negative 2y equals x squared plus 2x minus 1. And now, since we are going to want to create something that looks like this, so we want 4p times y minus k equals x minus h squared. In order for us to create this binomial squared, we are going to need to complete the square. So the process of completing the square, first we are going to want to isolate these two terms. So I'm going to add one to the other side. And then from here, we need to find the term that essentially completes the square. So remember, there is a little formula for this. The formula is b over 2 squared. So I can see that the number that's going to complete our square is a 1. So I'm going to add 1 to both sides. Please don't forget to add it to both sides. So what I have left here is negative 2 plus 2 equals, and if I factor that, I get x plus 1 squared. Oops, sorry, we forgot the y right in here. This is almost in standard form, but we still need to create this side of our equation. So I'm going to factor out negative 2, and we're left with y minus 1 equals x plus 1 squared. So now we have enough information to allow us to find the focus. So first we are going to want to start at the vertex, which I can see is negative 1, 1. And then we need to find that p-value. I want to remind you guys that this is 4p. So to find p, we can set up a little equation. We can say 4p equals negative 2, which means that p is going to equal negative 1/2. So that means essentially we're going to start at our vertex, and we're going to move down 1/2. Now, since we are moving down, that means that I'm going to take this p-value, which is negative, and add it to our y value, because the y value represents vertical motion. So I'm essentially going to subtract 1/2 from my y value, and that should give us the focus at negative 1/2. Now, if you're not comfortable doing that, you can always sketch it out. We can see that we're going to have a vertex like this, and we know that it's going to be a downward facing graph, so then you can kind of work through that to find your focus at negative 1/1/2. All right, go ahead and pause the video and give this problem a try. Okay, so for this problem, we are going to need to complete the square to create that binomial squared. This time we actually have a horizontal parabola. So once we've completed the square and put our equation in standard form, you should have 4 times x minus 1 equals y plus 3 squared. So we can see that our vertex is 1, negative 3, and that our p-value is 1. Now, since I'm moving to the right to get to my focus, I'm going to add 1 to my x value because the x value represents horizontal movement. Of course, you can always sketch out a graph to kind of help you visualize this better. All right, so now we're going to do a really classic type of parabola problem, and it's finding a tangent line to any point on a parabola. So parabolas actually have a really cool reflective property, and this reflective property creates a scenario where if we find this angle and we have this angle, notice there's a line that's drawn through your axis of symmetry which goes through the focus and then intersects that tangent line. These two angles are always going to be congruent. Now, if you look at this triangle that's created right here, you might notice that it's an isosceles triangle, which means that these two legs of your triangle are also going to be congruent. So we can use this information to help us actually create this tangent line equation. All right, so we're going to find the equation of a tangent line to the parabola y equals x squared at the point 1, 1. So really quick, let's sketch out what we have going on here. We know that we have a vertex at 0, 0. And we can see that if you look at where 4p would be, 4p is 1, which means that our p-value is 1/4. So that tells us that we are going to have a focus at 0, 1/4. Now, they want us to create a tangent line at the point 1, 1. So let's say that that's this point right here. Let's call this 1, 1. So there's really two things that we need to create a linear equation. We need one point on the line, which we have, but then we also need the slope. We have to find some way to get the slope of this tangent line. So our goal is to find that slope. And in order for us to achieve this goal, we need an additional point. Because to find the slope of a linear equation, we have to have 2 points on the line. So luckily, we know about the nice reflective property of parabolas, and we know that this distance right here, the distance from our focus down to our tangent line, from here to here, is going to be equal to this distance between the focus and the point of tangency. So we know that these two distances are going to be equal. I'm going to call this D1 and I'm going to call this D2. So if we can use this property, perhaps we can find this point, allowing us to find the slope, allowing us to create the equation. So we don't know what this point is, but we can call it, let's call it 0, B. So the first thing we're going to try to do is to define D1. So D1 is just the distance from here to here. I want to remind you that if I asked you to find the distance between two things, you would find that by subtracting. So the distance between this point and this point is actually going to be 1/4 minus b. I know that you would like to look at it and say, oh, it's 1/4 plus b, but I want to remind you that this b value is going to end up being negative, so we're going to subtract a negative. So we are just finding the length of this segment and this segment and essentially adding them up. But remember, if I asked you to find the distance between two numbers, you would subtract the two values, so 1/4 minus b. So that's the distance from here to here, and that's as much as we can define at this point. Now for D2, well, we can find the distance between 2 points just using the distance formula. So let's do that really quick. We can do 1 minus 0 squared plus 1 minus 1/4 squared. And if you simplify that out, it becomes 5/4. So we know that D1 should be equal to D2. That's our special reflective property that we just talked about. So I can substitute the values, and we can actually solve for b. So in this equation, I can see that b is going to be -1. So that means that that additional point that we needed to find, which was this point right here, is actually going to be 0, -1. Well, now I can actually make the equation of our tangent line. So with the 2 points that we know are at 1, 1 and 0, -1. So the first thing we're going to need to do is find the slope of our line. So we do 1 + 1 over 1 minus 0, and that's going to be 2. And then I actually see that this point is actually our y-intercept at 0, -1. So we know it's just y equals mx plus b, so -1. And that is the equation of our tangent line. So just to kind of review and walk us through this again, we knew one point of our tangent line, but to make equation, we also need to know the slope. And to find the slope, we need to know an additional point on that tangent line. So we use the reflective property of parabolas, and we set these two distances equal to each other to help us find this b value, which gave us our additional point. Once we had our additional point, we used the 2 points to find the slope, and we already knew the y-intercept. So this is our linear equation that represents the tangent line. Okay, go ahead and pause the video and give this last problem a try. Okay, so we kind of follow through the same process. This time our focus is at 0, 1/12 because our p-value is 1/12. So the distance between the focus and this point of intersection, we can call 1/12 minus b. The distance between the focus and the point of tangency is actually going to be 37/12. So we just use the distance formula there. When you set d1 equal to d2, you can solve for b, and it actually becomes -3. So that means that this point is 0, -3. So now that we know 2 points on our tangent line, we can find the slope of our tangent line, and then we can create the equation. Okay, that is all for today's lesson. Thank you so much for watching.